Okay, so let's start with a bit of a quality assessment of our warm sector for July 6th to July 7th. A good place to start is looking at average cloud cover. So as you might remember from previous forecast videos, this is represented by total cloud cover that's taking place, the average total cloud cover that's taking place by region. Anything in white represents more continuous cloud cover, and anything dark represents clear break. So this is all expressed as a percentage in terms of total cloud cover. So right now we are in the late morning of July 6th, and you're seeing a lot of breaks already starting to take place from southern Ontario to southern Quebec. A bit cloudier across southern Quebec due to that warm front still influencing the region at the time. And the northeast is also showcasing some pretty large clear breaks as well. Now, going into the afternoon, we're still seeing that taking place. This is now 5 p.m. in the afternoon of July 6th, and still those breaks are continuing. Going into the late afternoon into early evening, still a large amount of clear breaks are taking place, so we know that the sun is getting through. And now let's skip right over into July 7th. Now, at this point, we are seeing a predominantly cloudy section overspreading southern Ontario to southern Quebec, more clear breaks in southern Ontario. But in southern Quebec, you're seeing predominantly cloudy conditions as that front is lined up in the St. Lawrence Valley and going into eastern Ontario, especially, as well as that shortwave trough. So this could be a hindering element to limiting how much destabilization actually occurs. Now let's check the actual amount of destabilization that's occurring through our low-level lapse rates. So we would expect lapse rates to be steepening very quickly where the clear breaks are taking place. So as you can see, so we're at the late morning of July 6th here in this animation. So you're seeing those brighter colors starting to emerge, representing a steepening of low-level lapse rates, showing us that the sun is doing its duty. Now going into the afternoon, you're actually seeing that amplify as we would expect. And it's really overlapping well where those clear breaks are taking place. And then late afternoon, same idea, going into the early evening. And of course, we'd expect this to disappear into the overnights, and sunshine does disappear. Late morning of July 7th. We're not seeing a whole lot, and that's to be expected because as you remember from the previous animation for cloud cover, you're seeing that large band of cloud overspreading eastern Ontario to southern Quebec. So we would expect these brighter colors to be located farther south where those clear breaks are taking place. So let's go further into the afternoon, since this is also important for July 7th situation, the late morning to afternoon. So again, that cloud cover is very persistent. It is preventing the sun from getting through directly anyway. So we're not seeing those rapid destabilization rates that we saw the previous day. So this will be a limiting factor for thunderstorm severity as well. So now looking at mid-level lapse rates. So again, it's the same idea as low-level lapse rates, except we're looking at mid-altitudes of the troposphere. So specifically in the range of the 700 millibar to 500 millibar altitude range. And again, all these lapse rates are measured in Celsius per kilometer. So now into July 6th, let's go further into July 6th here, and we're not seeing all that much. You don't see those brighter colors taking place across southern Ontario, southern Quebec, the northeast. You're not seeing any of that actually unfolding. And going into July 7th, it's the same idea. So for July 6th, at least for July 6th, we do have those steepening low-level lapse rates, but for July 7th, this is another limiting factor, I would think, for destabilization, since we're not getting the low-level lapse rates that we would need to generate more organized thunderstorms. The mid-level lapse rates are also not cooperating. So this will help to temper instability to a large degree. Okay, so now looking at the dew point temperature, so this represents how much moistening is taking place and the moisture concentration for any given location. So the brighter colors represent, like the purples, the dark shades of blue, they represent the highest amounts of humidity that are taking place. So now into July 6th, we would expect humidity to be particularly high, and you're starting to see these purple colors starting to overspread eastern Ontario into southern Quebec. These represent dew points of about 70 Fahrenheit, which is about 21 Celsius. That's very high humidity. So that's in the morning already. This is 8 o'clock in the morning, July 6th. And then going deeper into July 6th, even see some brighter purples taking place, a dew point of 74. So this is getting close to extreme humidity across southern Quebec, eastern Ontario, portions of southern Ontario, and parts of the northeast. And now we're going to the afternoon. It's steady at about 74 Fahrenheit, and then that stays with us right through to the evening period, late evening even. This is 11 p.m. at July 6th, and you're seeing that actually holding together with us, suggesting that cold front is still to our north, but close enough to start provoking some thunderstorm development as it interacts with this very humid environment and those steeper low-level lapse rates that I showed previously. Now let's go into July 7th. So you're actually seeing very narrowly that the greatest amount of humidity is hugging close to that New York border in southern Quebec and going south of there. So this tells us that that cold front is somewhere along this boundary, somewhere around this area. So we know that the strongest or the highest amounts of humidity will stay farther south, and this will improve the stronger thunderstorm risk, I think, for the Northeast, like for upstate New York, going into Vermont, and portions of New Hampshire as well. So this area here, I think, will be especially ripe for July 7th. And remember that the steepening low-level lapse rates are joining forces with this high amount of humidification that's still taking place south of the island of Montreal, south of eastern Ontario, so pretty much into New York, essentially. Now, that doesn't mean that we won't see thunderstorms in this area. It just means that the most organized thunderstorms will be farther south of the border, I'm thinking, given where everything is lining up. Now, it could be that the warm sector, if this cold front retrogrades farther back to the north, it would allow for this sector, this more humid sector, to move or advance farther north to allow access to, or allow these areas to access this sort of humidification zone. So we'll have to see and watch how that actually takes place, if it does take place at all, and then that would start improving the chance for stronger thunderstorms in the Montreal area and neighboring eastern Ontario. Okay, so doing an evaluation of our lift at mid-altitudes of the troposphere, so specifically around 500 millibars, this is an estimate of vertical velocity. So as you might remember from previous videos, these brighter colors represent the highest amounts of lift that are taking place, the largest amounts of vertical motion, measured in microbars per second. That's what these units represent. If we go forward into July 6th, so this is still pre-dawn July 6th, going into the morning. This is now 8 o'clock in the morning. So let's go towards the afternoon, the late afternoon to evening, since that's what we're most interested in, and also the early part of July 7th. So notice that we have the shortwave trough that's also starting to evacuate to the southeast. So these brighter colors are starting to represent more aggressive lift taking place ahead of that feature. So as this starts to advance to the southeast, we're starting to see these brighter colors also following it like a magnet. So this is going into 5 p.m. July 6th, and we are seeing that really starting to move close to the Montreal area and north, and also west, and you're seeing a good zone of lift towards southern Ontario as well. So these are some pretty sizable maxima taking place here during, now this is the late afternoon, 8 p.m., because late afternoon is around 8 p.m. And now we're going into the late evening, and you're seeing the largest amounts of lift still staying to the north during the late evening. So there is a brief period, a narrow window of opportunity during the late afternoon to evening period where this zone of lift could amplify the chance for thunderstorms during the let's say close to sunset, where you can actually see this. Let's say traditional dinner time to sunset, where this lift could engage with the humidity that's taking place here, along with the steepened low-level lapse rates that we saw before. So this will be something to watch, I think, late afternoon. But then the lift seems to back off for the late evening and going into pre-dawn as it stays further to the west and northwest and further north and northeast. So we'll have to see if that actually does retrograde, but there is a window of opportunity, I think, during the early part of the evening and late afternoon where thunderstorms could emerge because of that lifting zone. Now going into July 7th, so now we're into pre-dawn July 7th, and going further into the morning, so this is just past sunrise, 8 o'clock in the morning, and we're seeing this area of lift, so another shortwave trough, or the same shortwave trough that's actually moving farther southeast and affecting eastern Ontario to southern Quebec, so this could be an area to watch as well, or the time frame to watch for July 7th's case. So I think the morning is also an area to watch for thunderstorm developments, organized ones as well, despite, as I showed before, the greatest amount of humidification is taking place farther south. So this lift is particularly strong, and I think it can be a substitute for the lack of destabilization that realistically occurs during these hours. Okay, so we know our principal lifting mechanism, in addition to the trough that I showed previously, is also that cold front that is lined up from the northeast to the southwest, and it's moving in this direction to the southeast, and pretty swiftly in some cases. But there are signs that it is stalling as well by the time it gets to southern Quebec. So let's do an evaluation of how much lift is taking place with this cold front as it moves to the southeast. So now we're at 5 p.m. July 6th. You're starting to see these brighter colors starting to appear ahead of that front. And also keep in mind, this is a very destabilized zone. We have a lot of instability taking place here. So late afternoon, 5 p.m., or mid-afternoon, 5 p.m., now going into the late afternoon, so 8 p.m., and you're seeing huge amounts of lift. And remember, we had that area of maximized lift associated with our trough, our shortwave trough. So together, this is helping to really amplify lift in this region, this zone, southern Quebec, eastern Ontario, and portions of upstate New York, and going west into southern Ontario, mostly north of the GTA, north of the 401 corridor in general. So that's another area to monitor for tomorrow evening, July 6th. And going to July 7th, so we don't want to miss out July 7th. So this is now like pre-dawn, and you're still seeing this lifting zone still hanging around southern southern Ontario all the way to southern Quebec. And now we're going further. So it's pre-dawn, this is later pre-dawn towards sunrise, and then 8 a.m. So you're seeing these colors still staying with southern Quebec, especially in southern Quebec by just after sunrise. So strong thunderstorms could still erupt despite a more limited environment. These lifting zones are pretty strong, I think, to still generate a few organized thunderstorms. So this will be something to watch, I think, into early July 7th before this lifting zone. So let's go a bit further to show where that lifting zone is going. So that cold front is being shown to drift slowly farther southeast, and that's why we're seeing these brighter colors starting to follow it farther south and southeast as well. So I think by the afternoon of July 7th, the risk in southern Ontario to southern Quebec will start to, or will already have diminished extensively. So the morning period, I think, of July 7th will be important, in addition to late afternoon or mid-afternoon to late evening of July 6th, and even pre-dawn of July 7th. Looking at CAPE, so convective available potential energy, this is a metric of instability. So the larger the CAPE, the larger the amount of instability. The brighter the colors here represents larger CAPE, and therefore, again, larger amounts of instability. So this is the morning of July 6th, around 8, and we're seeing zones of 500 joules per kilogram for CAPE across southern Ontario to southern Quebec. And as we go into the afternoon, we expect brighter colors. So now we're seeing these shades of blue and even some patches of green taking place here to represent higher amounts of instability. So these represent anywhere from typically 1,500 to as much as even up to 2,500 joules per kilogram in some of these zones. But this is moderate instability. That's what this represents. But as you might remember, mid-level lapse rates are pretty limited. So I think that's what's putting a lid on how much instability actually takes place in this environment. So because of the weaker mid-level lapse rates, I think that's limiting correspondingly how much total CAPE is actually taking place. If there were steeper cooling rates aloft, I think this would have helped to energize the amount of instability taking place here, and you would see even brighter colors, maybe even approaching 3,500 joules per kilogram if that was able to join forces. But alas, we don't have mid-level lapse rates really working with us, both for July 6th and July 7th. So this is really what we'll get because of the moistening effect and the sunny breaks that we will be seeing. Now, going to July 7th, so not to leave out July 7th, so this is pre-dawn. We're still getting large amounts of CAPE for pre-dawn despite no mid-level lapse rates. Now going into the morning, early morning, and later morning now, July 7th, so 8 a.m. to 11 a.m., we're still not seeing all that much instability, and this makes sense because the mid-level lapse rates are still absent in large part, but we're still getting a decent amount of moistening, and those lifting features are in this zone right now of eastern Ontario to southern Quebec. So I think this is still enough instability to work with to generate at least a few organized thunderstorms, as I mentioned before the cold front and our shortwave trough evacuate into New York and Vermont. Okay, so synthesizing everything we looked at previously, this is a Skew-T log P diagram. It's taken at the west end of the Montreal area, the Island of Montreal, West Island specifically, for 5 p.m. July 6th. We zoom into July 6th, 5 p.m. because that is the starting point of when thunderstorms start to become more important for not just the Montreal area, but neighboring Eastern Ontario and around the Montreal area in general. So Looking at this plot, so as you might remember from previous videos, the way we read these is by looking at the environmental temperature represented by the red curve, and that shows us how temperature is changing with increasing altitude. The green curve is our dew point temperature, so how humidity or moisture is changing with increasing altitude. So just take note, we have an 89 Fahrenheit temperature at the surface. So the surface is roughly along this white line, this first white line going across to 1000 millibars. That's where we are. So we're seeing this 89 degree Fahrenheit maximum at 5 p.m. That's not surprising since tomorrow we're seeing some strong warm air advection taking place in addition to the amount of sunshine that's still getting through. So I wouldn't rule out an 89 or even up to 91 degrees Fahrenheit tomorrow. So that's about as much as 32, maybe even 33 degrees Celsius. I think 32 is more reachable, but 33 is not, shouldn't be ruled out. And we could see our 72 degree dew point representing very high humidity. This could send our humidex into the 40s once again. So the newest day spent with a humidex of 40 to 41 degrees. So yes, it's a very hot day tomorrow. I would say it goes without saying that tomorrow is a very hot day. It's the hottest day easily for this month so far, and one of the hottest days so far this year. And one other attribute I want to mention is this dashed blue curve representing our parcel temperature and how that's changing with increasing altitude as well. And anything between that environmental temperature curve, this red curve, and this dashed blue curve is instability. And since our parcel temperature is to the right of this red curve, it represents instability, also known as CAPE. So we see a CAPE value of about 2,500 joules per kilogram occupying this area. So that represents a pretty sizable amount of humidity and is distributed over a great tropospheric depth, which does suggest to us some rigorous updraft development for some of these thunderstorms. It's not particularly fat CAPE, because you don't see particularly huge differences between our temperature, but it's still a pretty good difference at different altitudes between our environmental temperature and parcel temperature. Now, just moving on to these wind barbs, this shows us how wind speed and direction are changing with increasing altitude. And we're seeing within the boundary layer, which represents this slice of the troposphere from 1000 millibars to 150 millibars, and you're seeing this area showing some veering. So we actually have a southwesterly wind flow at the surface, the way this wind barb is pointed at the surface, and it's fairly breezy. And you can see how that's changing more to west-southwest to even westerly by the time you get to 700 millibars. So yes, it is actually a good amount of veering. Well, not a good amount, but it's a decent amount of veering that's taking place here. And this could invite some rotating thunderstorms within the thunderstorms that actually do form. At least a window of opportunity for them to take place around 5 p.m. At the 500 millibars altitude, we are seeing some stronger wind fields taking place, some westerly winds. So again, you can see how these wind barbs are oriented and indicates westerly winds. So if we're looking at the 500 millibar temperature, so moving away from wind speeds for a moment, we're actually seeing this temperature around, let's say, -5 Celsius. So it's not a particularly cold 500 millibar temperature. So I think this is still going to act to limit how much hail production actually takes place. And it will also limit the damaging wind hazard, I would think, because first of all, these wind speeds are not particularly strong at this altitude, and it's pretty warm as well. Well, I emphasize warm. It's not like warm, but for 500 millibars, this is pretty warm. So I think the hail hazard and the locally strong straight line wind hazard will be more negligible in this situation. It's not just the 500 millibar altitude, but it's mostly the surrounding altitudes as well. And this makes sense if you remember the mid-level lapse rates. We're not seeing particularly steep lapse rates. So that's more of a reflection of what's going on at the mid-altitudes. Now we go one more time step. Now we're into the late afternoon. This is 8 p.m. July 6th. And really just two things very quickly I want to share with you is that we're still seeing a large amount of instability. So this is about 1,500 joules per kilogram, and it's distributed over a large tropospheric depth. It's fairly skinny CAPE. Also, another factor is a more distinct veering component within the boundary layer for the wind fields. So we're getting a southerly component at the surface, and this quickly veers towards a southwesterly component at about 150 millibars. So this will keep the rotating thunderstorm or supercellular thunderstorm structure intact for the late afternoon period as well. So yes, supercellular thunderstorms will be possible, at least briefly, for the late afternoon period. So mid to late afternoon, given the strengthening veering profile that we're seeing, in addition to some pretty strong CAPE that's taking place here. So this will be something to watch as well going forward. Okay, now looking at a sounding during pre-dawn July 7th, so it's actually near It's actually near sunrise, so late pre-dawn into sunrise. And again, you're actually seeing Cape still with us over a very skinny kind of orientation from the surface above. So there is close to 1,000 joules per kilogram in this case distributed over this skinny section. And our wind profiles are actually a bit stronger, but in terms of a speed shearing component. Now at the surface we have a northeasterly flow, so this suggests to us that the cold front is narrowly to our south at that point, but we're still seeing some high humidity and some strong wind profiles, some stronger speed shear profiles taking place. And you can actually see that around the 500 millibar altitude where these wind barbs are more aggressive, pointing from the west-southwest. At the same time, I did mention this previously. I did mention that the hail threat should be minimal in this situation on July 6th. But into July 7th, I still don't see that much probability or that much of a probability for hail production altogether. But with this drying kind of profile, so we have this hydrolapse, and that's represented by the quick decrease in humidification that's taking place around these altitudes. So this slice of the troposphere, you're seeing some pretty rapid declines in humidity. That's what we call a hydrolapse. And this is showing us that humidification is decreasing quite rapidly. And therefore, this could actually cause more dry air entrainment, which could in turn lead to a substitute for promoting some stronger local downbursts from some of these thunderstorms that do develop during the later morning period. This should be limited since our instability factor is much weaker. So I think the primary hazard would be the heavy rainfall for the pre-dawn period or near sunrise of July 7th. I'm going forward towards the morning period. So I won't show the rest of the morning, but this is pretty much intact, I think, going forward and for the next few hours that occupy the morning. So I think the heavy rainfall rates will be the primary hazard with this, and there's still some opportunity for some intense lightning with some of these thunderstorms, even though the greatest threat for that will be farther south. Okay, so just quickly putting all of this together, so where I think the prime initiation zones will be. So firstly, let's start with our cold front. So we know a cold front will be affecting July 6th during the mid to late afternoon period across southern Quebec, southern southwest Quebec, and going into portions of the eastern to southern Ontario. So we know our cold front will be positioned in this sort of fashion. And based on where the maximized areas of lift are, I expect thunderstorms to start initiating in this area mid to late afternoon tomorrow, and also just north of the 401 corridor. Ultimately, I think these thunderstorms will be moving in that direction, initiating in these circled areas along that cold front. Okay, so focusing on these zones, so like around the island of Montreal and just north of the 401 corridor along this zone, and even a portion of eastern Ontario over this way. So we know our lift is greatest in these regions based on the frontal boundary, the shortwave trough joining forces during the mid to late afternoon of July 6th. And I think the dominant hazards will be particularly heavy rainfall. So I do expect a flash flooding possibility or potential in these zones where the most organized multicells start to take form. Now, also keep in mind before cell consolidations occur, just based on those wind shear profiles that I showed, that veering component, especially late afternoon, there is a narrow window of opportunity for an isolated weak tornado as some of these thunderstorms do become at least temporarily supercellular. So I'm thinking that that's another hazard. The hail hazard, I think, will be limited just based on the 500 millibar temperature. But there is also some opportunity for some locally strong downbursts, mostly because of that hydrolapse that I showed before, in which the humidity is decreasing very rapidly with increasing altitude in those hydrolapse zones, right? So this could act as a substitute for locally strong winds. So I think those are the primary hazards. At the same time, lightning can also be intense. We do have very high humidity at the surface and dry air aloft, so I think this is the right combination for intense lightning with some of these thunderstorms as well. So tomorrow mid to late afternoon, I would expect some intense lightning with the most organized thunderstorms in this zone as well. So, but this, just know that these represent lightning strikes, intense lightning strikes. So yes, among these, some high energy strikes as well. And then going into pre-dawn on July 7th, towards even lunchtime, especially in southern Quebec, there should be another opportunity for some multi-cell thunderstorms. And again, I think the primary hazard with those would be the heavy rainfall rates. So again, another opportunity for significant water accumulation in these zones. So it'll be something to watch. So if you made it this far, thank you very much. I really appreciate your attention. Always appreciate your attention and making it this far and sticking with me through all of this. I know it was a lot to digest and process, but I think it was also necessary given the situation that could potentially be faced in these regions for tomorrow afternoon into the early evening, and to some degree in Southern Quebec for the pre-dawn to late morning period of July 7th. So ultimately, if you found this useful to you, if you found it insightful, feel free to subscribe to not miss out on upcoming forecast videos. And in the meantime, I will leave you with these playlists, so feel free to check them out. And until then, once again, thank you very much, and I will see you in the next video. Thank you so much yet again. Cheers.